Welcome to MMT Ask the Expert. This episode brought to you by Husky. Melt to mold precision. Today I'm here with Derrick Hennebicque, Hot Runner Product Manager for Husky Technologies, to answer some frequently asked questions about Hot Runner product benefits, maintenance, and refurbishment. Hi, Derrick.
Hey, Christina. Thanks for having me.
So let's jump right in. Let's start with Hot Runner product benefits. What are the different valve gate actuation types? What are their limitations and what are their benefits?
Yeah, I guess when we talk about valve gate actuation, there are really two components to that. There's drive media, which is the first thing I'll talk about. So valve gates are really just moving a valve stem or a valve pin in and out of a gate orifice, that orifice which feeds the cavity. So that can be driven by three different media. There's hydraulic, there's pneumatic, and there's electric servo. Hydraulics and pneumatics have really been the classical version or the classical media for moving that valve pin in and out. And electrification and servo motors have really taken off in the past dozen years or so. But a lot of Husky, we've offered pneumatic really as our primary media for actuating valve gates, but we also have hydraulic and electric options. But that really moves us to the second piece, or to the second category, which is what I call the vehicle. So a valve stem is moved forward and back, or to open and close position, but it's what drives that valve stem, or what that valve stem is hanging on to. So the classical version of that has been the single actuator. For us at Husky, that technology has been the single pneumatic actuator. That means that there's one valve stem or one valve pin, and it's connected to a piston, and it uses air pressure to either move the stem forward to close position or open for filling. But also in the past dozen years, along with electrification, group or plate actuation has really been stepping it up and coming along. We have our UltraSync technology, which offers plate actuation. And really what that means is all of those valve stems or all of those valve pins are all tied to a single actuator. That means that when that single actuator moves forward, all the stems move forward. When that single actuator moves back, all those stems move back, all at the same time. Very much like an ejector plate on the moving side or on the B side of the mold. The nice thing about that also is that can be operated with any of those media, pneumatic, hydraulic, or electric servo. But to bring it all together, everything has its pluses and its minuses. When it comes to hydraulics, you've got a lot of great power density in a very small unit. When you have pneumatics, that's extremely convenient. Nearly everybody has air pressure, even though the pressure is a little more difficult to generate for high pressures rather than hydraulic. While electric servos really offer a lot of great, it's extremely clean, it's extremely specific, and you can get a lot of traceability or trackability out of that. But when we talk about valve gates in general, the challenges can be space. So you can be really challenged in some cases to get a whole lot of cavities in a really, really small footprint. But every hot runner supplier has ways to get around that, and usually starting cost. So a valve gate will typically have a little bit of a higher cost when it comes to a thermal gate. But the benefits of all of the above are you get less variation, whether it's cavity to cavity or shot to shot. And you get much better gate quality out of a valve gate, all the time, every time, than you would to a thermal gated system.
Got it. Consistency. All right. Well, that's a great snapshot. Okay. So when specifying a hot runner system, what are some of the key performance criteria that you have to look at?
I would say the first thing is what's the yield requirement for those parts. If you're making millions of parts a year out of the same mold, a hot runner is definitely the way to go. But if you're only making a few hundred or maybe even a few thousand, sometimes that's something that needs to really be considered. However, there's an exception to every rule. And when it comes to prototype molding, with the goal of mass production, that's when it can be really, really helpful. So you may only make a few hundred or a few thousand prototype parts, but having a hot runner on there is just as important. It may not be a one-to-one between your prototype and your high cavitation system, but it's going to give a lot more of an indicator of what can be affected, what can be controlled, and what may need to be considered, not only in the build, but also in processing. Going back to the previous question, cavity spacing is another thing to consider. So sometimes we will see somebody, sometimes a first timer, sometimes even a hardened veteran will come to us and they'll say, here we go, we've got a really high cavitation system, let's call it a 64 or a 96 or even 128 cavity mold. And we want all of those cavities or all of the gates to those cavities to just be 15 millimeters or 5/8 of an inch, just dip to dip to dip to dip to dip. And that's a really tall order, because when it comes to hot runners, we're not only trying to deliver melt from a single point A, that machine barrel typically, to all of those points B, all of those cavities, but we're also trying to get it there at the same rate, at the same temperature, and it takes a lot of equipment and hardware in order to do that. So that second piece is really about gate access. Number 3 is cooling. Cooling is incredibly important to injection molding. We're taking a material that's in its molten state and we are pushing it with pressure into a cavity to take a form. We're using that cooling to remove heat, make it solid enough so that when it ejects out of the cavity, it doesn't deform. But cooling also has an effect on the hot runner. Remember, we're trying to take that material, which is molten, and we're pushing it into the cavity where we want it to go solid. And the boundary in between the two is infinitesimally small. So what's really important is to remember is that the cooling of the cavity doesn't necessarily apply to the temperature management of the hot runner. The hot runner still needs cooling in order to maintain plate temperatures, to maintain loads, to maintain expansion, but it doesn't need to have as strong a cooling as it does in the core. So if you have extremely strong cooling and you have a resin that is incredibly sensitive to temperature, like say a nylon, that can really affect some of the processing, and it can even affect some of the performance and some of the expectations. So not to say either way that cooling is bad or cooling is that cooling is important, but it's not that cooling is bad. It's just very important to remember that cooling also has a very strong influence over hot runner performance and hot runner consideration.
Got it. All right, let's talk part quality. Can you give some specific examples of how hot runner technology has impacted part quality?
Yeah, maybe rather than specific examples, I can talk about the general ones, because those really have applied to so many scenarios. So hot runner molding is very often called runnerless molding, and removing that runner from the overall injection molding process really does a lot. It can eliminate secondary operations. It can eliminate the need to do any sort of runner grinding. So now you don't need regrinding equipment or material handling, equipment handling, or maintenance when it comes to that. And finally, overall, it's less handling in general. There's less to move, less to worry about, less to transport, less to buy, less to pay for. But the next thing that comes out of that naturally are faster cycle times. So if you can remove the portion of the molded product that has the thickest wall and takes the longest amount of time to cool because that's the thickest, that's really going to be the runner and the sprue that's supplying melt to the cavity. If you can remove that from the entire molding equation, that's something that doesn't need to be cooled down. And that's just a little less cooling time that can sometimes shave seconds off of a cycle. What that can also offer as far as a faster cycle is now you don't need the open stroke of the mold to be as great, typically, to clear your sprue, to drop a robot in there to pick out a runner, or to make sure that that runner clears along with the rest of your parts. And then finally, as far as impact part quality, I'm going to use a pretty simple example here, but gate location is there's so much more to choose from as far as option and diversity when it comes to gate location on a part. So, and that gate location, we all know, really affects the processing and the processing performance of making a part, but also the part's properties itself. So that can really affect things like fill pressure. It can affect material temperature or fill temperature, and it can affect the fill pattern as the flow front moves through the part. So if we were to think about, say, a disc or a Frisbee, if we weren't using a hot runner, we would typically need to gate at the perimeter of that disc or the perimeter of the Frisbee. Certainly, we could go someplace in the middle with a cold runner, but that would be a much more complicated mold. And that complication means more expense, more effort, more time, just more to pay attention to. But if we were using a hot runner to fill that disc or Frisbee, now we can put that gate or that drop right in the center. What's nice about that is the flow front is going to flow out. That's going to use fountain flow. It's going to flow out radially. It's going to have a much shorter flow path from the center to the perimeter than it is from the outside going all the way over to the other side. And then finally, I would say the biggest impact to part quality that hot runners offer is adjustability. So a hot runner offers so much adjustability. You can change a setting or a set point, and 5 minutes later, you can change it back. And you can do that cavity to cavity. You can do that for 5 cycles if you want to. You can do it for 100 cycles if you want to. You can jump around all over the place. That's incredibly difficult, if not impossible, to do with a resin, to do with a machine, to do with your platen or your mold. It is possible with a mold, but it takes a really, really, really long time to do that with a mold, just because molds are built to last and to operate for a really, really long time in the same state. So that adjustability and flexibility of the hot runner is so important, and it can be so helpful when it comes to modern molding.
All right, so that takes us nicely to maintenance and refurbishment. So when is the best time to PM a hot runner system, and what does the downtime typically look like?
Yeah, it's a matter of benchmarking your mold and your molding cycle and making sure that everything is performing and continuing to perform as necessary. Most factories like to operate under a biannual or an annual. I guess we could call that a semi-annual, every 6 months type of PM, just because there's usually a down season where a lot of people are leaving to go on vacation, typically in the middle of the summer. So that's going to offer a lot of time as far as availability to perform a PM. Now, the next part of that, of course, is that where it depends as far as how long that it takes.
Yep.
So that really depends on the construction of the hot runner. Are you talking about a thermally gated system or a valve gated system? Are you talking about a very low cavitation mold, such as 2 or 4, or are you talking about a very high cavitation mold, such as 96 or 128? Or is it something that's incredibly complicated and incredibly intricate, like a stack mold? And because all of those things affect handling, it affects time, it affects the components that you need, the components that you need to fit, and the components that you need to, or rather the heaters that you may need to rewire when you perform a preventative maintenance. So now let's just throw some baselines out there. A low cavitation mold or hot runner could take probably about 3 days, give or take a day. But then something that's a very high cavitation could take a week or possibly even longer to do. That's not so much about zipping out all of the bolts that hold everything together, but it also has to do with making sure that everything is torqued properly, and especially making sure that everything is wired up properly. I would say that wiring and ensuring that connectors are connected and robustly done so without any sort of half-done splicing or anything like that is really where most of the time is going to be taken up. Now, sometimes factories are limited, especially nowadays when it comes to resources such as available capacity and people, but also skill. So this is a really, really great opportunity, I guess you could say, for me to just explain that Husky does offer hot runner refurbishment and inspection as a service, where you can talk with our teams for scheduling a refurbishment. You can plan out the scope of that refurbishment, such as and pre-order all the parts that are necessary to do so. But you can also take comfort in the fact that when that hot runner is refurbished or rebuilt, that it's in like new condition, which means all your heaters are tested, all of your tip heights and your stem heights are checked, all your air circuits, all of your seals are all going to be like new because they're all going to be replaced.
Nice. That's a nice service. And you're right, definitely needed in this age of lack of people to do that kind of work.
Yeah.
So what is Husky doing to extend the maintenance intervals?
That's a good question too. So, extending maintenance interval is really about evolving product and evolving knowledge. And that's something that we're always doing here at Husky. So whether it's new metals, new coatings, new surface treatments, those are all things that are constantly evolving, coming out of the woodwork, and that we're constantly investigating to see how those all work into hot runner construction, but also hot runner operation, because we're not only looking to extend maintenance interval, but we're also really looking to make sure that that three-legged stool of maintenance, performance, and reliability is always pretty level, just because you might have one, but you may need to sacrifice those two others in order to achieve it. But then finally, feedback is so important. So we are not only looking inward or looking outward, but we're also taking any feedback that comes from our customers about our products. So this might be a really good way for me to say to everybody out there in TV land that if you're observing any sort of performance with your hot runner, talk with your hot runner supplier, talk with us about that. Things that you're seeing that may not seem as if they're working properly, but also let us know what you're seeing that works incredibly well. That feedback is just as important, because we all can't just operate in a box or in a vacuum.
Exactly. Communication. Well,
Yes.
that's a great way to end this segment, Derrick. So thank you for your time and for your insight on this topic. And to those watching, be sure to check out the other 3 installments of the special 4-part series on hot runner technology, brought to you by Husky Technologies, right here on moldmakingtechnology.com.
Thank you, Christina.